Hello, my dear students. Good morning, good afternoon, good evening. Don't know exactly what is the time in your country right now. That is why. Hello, my dear students. And once again, we are talking about manufacturing of assembly jigs. Before we get starting with explanation how to assemble assembly jig from separate pieces, let me to remind you what jig typically consists of. What do you see now in this picture? It's assembly jig, a real assembly jig that we have in our laboratory class for assembling the flap. Do pay attention that. Now, let me to remind me that someone who have repaired the jig, have restoration work as to the jig, made mistake in coloring of it, because red color in real life, it's used only for mock-ups. It's used only for special tooling. No, you might see something at the floor, like mounting standard, mounting plate. It's supposed to be of another color. Don't pay attention. Very beautiful, but wrong. What do we see? And in addition, it's difficult to notice the contour in such a color. What do we see? That we have here contour of flap vertically, as you might see, with the nose edge, with the leading edge to the bottom and the rear edge to the top of the jig. And each couple of contour locators repeating the contour of flap. No, not much visible. By the word, do pay attention that distance between these locators, it's around of width of my fist, and I hope you understand that woman fist it's not much, and it's the question about convenience of work in a jig, in order you understand that elements are placed rather tightly. Pay attention that each of contour locators fixed somehow to the jig frame, to the jig skeleton. What this is somehow? No, in our country, in our countries of former Soviet Union, it was typical to use so-called barrels. What now you see empty places, empty barrels. To use such barrels, they are with holes because we are going to fill it with cement. And next into such barrels, we're inserting fork type connector, or it's maybe called I-type connector, up to you. And such connector has the attachable actually joint with contour locator, but only one side. In this jig we have bottom elements which are openable, and at the top they are movable like hinge, but they are not openable normally. So what jig consists of? Once again, what jig consists of? We have skeleton of jig. Usually we call it frame-like jig because the whole skeleton was originally assembled as the one structure, or it may be column beam type structure, like in our mock-up that you must have seen in class near the door. That one consists of separate columns and beams, top beam and bottom beam. And to such a skeleton, we are just hanging, in our case, locators of contour. In order to hang these locators of contour and to have finally correct contour of all the flap in each couple of locators, quite clear that we must align somehow contours of these locators. In our previous laboratory class, this problem was solved by using the special tooling. This special tooling, but really special, it means it's unique, it's appropriate, it's usable only for one type of aircraft. The red one, you see, it was mock-up of the wing, mock-up, which we call mounting standard. For manufacturing the mountain standard itself, we made first this yellow element of tooling, mock-up of the whole surface standard. Next, we copied it via the counter standard, something very similar to the jig. And in this counter standard, we have created the mounting standard, which we next using for manufacturing the jigs itself, themselves, let it be. And it was one way how to produce the jig, how to mount the jig immediately in a shop. You may use special carrier of sizes, either it's mock-up, like in this case, or it's a template, like it was in our very first lab. And we are attaching everything to this special carrier of sizes. Or another way that we are going to study today is to use some elements of these locators instead of contour. Instead of contour of locator, now we're going to align another elements of locators. And these another elements are exactly these holes which used for joining locator to the jig, seems like only. We are going to align these holes onto one line, and due to this, all contours in jig also will be aligned. It's approach which is called instrumental approach for mounting, to jig mounting, and it means that we are using measuring instead of copying sizes. Here, copying approach, measuring approach. What else do we have in such a jig? Normally, we have also locators of holes, locators of holes of different types. Here in the jig, you might see locators of GBH. You not see a hole. Here is, you see, thick pin. Let me to show it more closely. You see very thick pin, and this thick pin actually is a pin for locating the part bracket with big hole. On this side, on that side, they are both locators, and these locators are movable. You may remove the pin, move locator inside in order to adjust here the part with holes, and to put it in, to put it on. No? And next, how to understand where locator supposed to be. Easy peasy. No? We have here a hole, and if locator in correct position, this hole both it's penetrating, like passing through the housing part and the pin. And if locator in correct position, it means that hole in housing part and the pin itself, they are aligned, you see. No, it's not the matter of our today laboratory work. Just do remember, please, that we have locators of contours. Here they are represented with red color. Actually, they supposed to be either of silver color, as you might see here, of green color, as you might see there in another jig. Normally done, but not of red one. And locators of holes. Locators of holes, GBH holes, as you see here, there, and locators of base hole or coordinate fixing hole. No, in this jig exactly they are not represented. So once again, which holes we are interested in when we are locating these contour locators, as they are called. We're interested in the holes which are actually auxiliary holes. They are not important, really. In the jig, they are not important. They are using only for joining locators immediately to the frame of jig. Why we are interested in them right now? Because they are going to substitute measuring base. I hope you do remember that measuring base of any aircraft, measuring bases are so-called main building or main constructive planes. Plane of symmetry, constructing plane of the wing, constructing plane of stabilizer. We're measuring all the sizes we are counting all the sizes from these planes in drawings. And this axis, it exists really only in drawing. We can't attach this contour locator to the empty place. We can't find position of this contour with respect to the empty place, and we can't imitate it somehow. So we substituting the base. Instead of this non-existing plane, we are going to use holes. Plane with holes. All these holes, they are aligned onto one line, typically along one line, and they are all on the same axis, and they are all coordinated to this not existing plane. How they are coordinated? In a drawing, of course. In a drawing, it's given the size, and first you need to reproduce this size in contour locator. We are going to produce locator which accurately reproduce sizes of contour with respect to this not existing plane, and sizes of hole, actually position of hole, with respect to this not existing plane. On one hand, we are manufacturing locator itself with its contour and holes. On other hand, we need to produce these beams. To find position of such four connectors, correct position, they are holes actually, these mounting holes they are called. We need to find their correct position on beam now. In order, next, when we are just hanging locators by these holes onto the beam, all these locators, system of locators, give you the whole surface of aircraft that you need. It's so-called measuring approach or instrumental approach because we use special tooling, instrumental. Now you see exactly this tooling. They are so-called instrumental rulers or instrumental scales. Do pay attention, they are not really rulers that you get used to see. How may they measure something? They may measure only distances between holes, and moreover, you might see that not all the holes they may measure distance, not any hole, but only holes that have sizes equal to 50, 100, 100, and so on, because they are made in grid 50 millimeters, 5 centimeters, 10 centimeters, 15, so on. No? All these things, they have fixed size. And they may help us to count, to find sizes, as I already said, that have step 50 millimeters, and only for holes. We have already agreed that we substituted the flat base, linear base, to these holes, and that is why it's quite convenient for us to use something like this. Moreover, you see that some rulers, they have only one line of holes, some rulers, they have some line of holes, and I hope you do remember in photos you have seen that we have even special tables, and these tables also have step of holes 5 centimeters, 50 millimeters, and these tables, they are rather wide and long. They are so-called coordinate tables, universal coordinate measuring tables. They also may be added with special devices for making the third coordinate. Here you under the table you might see something. Okay, I'll show it later a bit. And now let's talk about the first half of our laboratory work, I guess. I already said you that we are going to make locators. What does it mean we are going to make locators? We are not really cutting them. They already pre-produced. But as you might have seen in previous video, that is you may see it better. We have bushings, and these bushings must be real bushings. They are rather big. They look like, and we may use pins. Guys, it's already third time I'm trying to make the same thing. Explaining next, it's appearing that I did something wrong with camera and video is not working. Once again, I'm afraid that I may miss something because I repeated it 3 times. Once again, we have real bushings that looks like this. We have towing bushings, you see. And what about these locators? Where we should place the bushing in locator? Somewhere here. Where exactly? You see that hole is much greater. Hole is much greater than locator hole. And in contrary, locator hole is much greater than bushing itself. And you need to find where bushing exactly in this locator with respect to the axis. But, do forgive me, where is the axis? What is correct position of locator? Like this, like that. Axis is far, axis is closer. Maybe this locator does not repeat all the contour at all. How to find correct position of bushing with respect to the axis that does not exist? I remind you once again that this technique has appeared before appearing of CNC machines, computers, or something like this that greatly improve our life in terms of manufacturing the tooling. And what we are going to study now, it's in use now also. It's used together with using of computers, 3D models, and CNC machines. It's important to understand. Так, let's try to start again. What do we see now? We see coordinate table, but this coordinate table represents us only one line of coordinates. In our toyish mockup, toyish table, we have holes in a scale 1 to 5. As far as I remember, because here you see instead of 5 centimeters here, you see 1 centimeter between holes. And anyway, 5 centimeter, 1 centimeter, we have only 1 lines of holes. It means that we need to add here additional elements, orthogonal elements, which create us an orthogonal system of coordinates first. And next, in order we may see exactly where this axis, we are going to use tooling template. This tooling is necessary to show us where the axis. This tooling will create us measuring base. Let's start. Let's continue. Do forgive me, I do not show you all the process in order not to waste time. And what do you see now? What I did? You see, I took a couple of coordinate rulers. There are, as I said, imitators, toyish one, in a scale 1 to 5. I placed them at the table on appropriate distance. This appropriate distance is equal to the distance between holes in templates. You see the template has special information like hair lines and it has a couple of holes. Base hole here, base hole here. Both of holes, they are on the axis. And this template is necessary to show us exactly this axis above the all. In our coordinate system, it's basic line. What we are going to do next? Next, according to the drawing I will show you a bit later, we will place here, according to the mounting scheme of our jig, we will place here a couple more rulers, fix them, place here these locators, and while placing locators, we compare how to find position of locator with respect to the template. No, somehow it's possible, yes, contour must coincide, but also we may do it a bit better or a bit worse. How to find correct position? Preliminary, these locators been made with correct contour, and also they have hair lines, and by these hair lines we are comparing where the place of locator with respect to the template. By the word, at this moment also it's possible to make final checking of the contour of locator, whether it's correct or not, this couple of locators altogether. And task will be find position of little bushing. I hope you see now. Now, it's not final position of ruler, of course, I'm just trying to explain you somehow now what we are going to do next. You see that position of hole in ruler mounting hole, future mounting hole of this bushing must be repeated with very high accuracy with respect to contour, as I said you, with respect to the contour of this locator, and both position of hole in a bushing and contour of locator, they are related to position of this axis. Certainly, people, not my day today. I'm starting again. Look at this. We have drawing, and in this drawing we have information about position of bushings with respect to the axis. With respect to the axis of airplane, to the constructing plane of our wing. And quite the same should be repeated here by measuring. Why we measure it with such weird rulers? Why we don't use usual rulers that we get used to? Because, my dear gentlemen, we have to measure something with high accuracy. What is accuracy of usual ruler with divisions, with 1 millimeter divisions given by hairlines? Do you recollect, please? Plus minus half of division. It means plus minus 0.5 millimeters. What is accuracy of such a ruler? Accuracy of measuring by such ruler is plus minus 0.1 millimeter, 1/10 of millimeter. And accuracy of ruler itself, real ruler, plus minus 100 of millimeter. So accuracy of measuring with such ruler is 5 times higher than accuracy of measuring with more detailed rulers that have 1 millimeter division that you get used to. And additionally, it's a matter of stiffness. I had shown the lid already for you, but I'm afraid this video has not been stored. Look at this lid of this, something like a roof for this tooling, made of metal, and it's around, it's more than millimeter at least. And pay attention what happened to this metal when one woman finger push it. You see, size, shape is changed, size is lost already. And what happened to the metal ruler if we are working with long objects? How do you think? Of course, this metal ruler might be deformed under own weight, and it means that metal ruler that we are going to use, at least it should be very thick. It must be massive. And that's what you see here. Massive, thick rulers, but instead of hairline divisions, we have holes. And these hairline divisions, non-convenient for us, not necessary for us, no? They are substituted with holes. Well, once again, we have drawing of these locators we need to produce. Accuracy of holes is given in specification, in technical requirements. And something similar we are going to produce. And we have mounting scheme. Better you might see it in photos that given for your laboratory class. No, I hope you understand what you see here. It must be repeated there. Pay attention to this scheme. What do we see? We see here the table like this, but this table we have rulers in one flow, in one line. This table supposed to be added with additional rulers, like second flow of rulers. What for? It's a story about double guiding base that you're supposed to know, that when you have to direct something more accurately, to locate something more accurately, better to use double guiding base. What is it, what it looks like, we will see a bit later. Now, once again, we are going to find position of another couple of rulers with respect to the axis of template, and according to our drawing, to mount all the coordinate system, all this orthogonal story, let's say, yeah? And next, to find position of bushings. Continue. What do you see now? Now you see it's correspond to what we have seen in a drawing. There are two flows of rulers, and this second flow, it's necessary to direct better the pin that we are going to insert here. Now it's without bushing. Let me to show you somehow. No, too much visible, too much dark. Maybe, but I hope you see it's inserted in couple of holes, and when it's inserted in couple of holes, it's more reliable in direction, in locating, than if we insert it into one line of holes. Even with real one, they are extremely accurate. No, of course, our ones in laboratory class, they are already not so brilliant, no? Because they used by students. But you see that it has some deviations with respect to the hole. And even these high accurate pins, they supposed to be located, passed through couple of such rulers in order to have more reliable locating during the measuring. So what it looks like, do pay attention. We have orthogonal coordinate system. No, really trying to show you that it's orthogonal. And this orthogonal system is additionally stuffed with template. Template is necessary to have base, some plane or line for measuring. And next, with respect to this line, we are going to count where must be. Really, it's easy to count because you see here we have, we may count holes, and by counting the holes, we may find position of, don't know how to show you better, we may find position in order you may understand that it's really a system of holes which coincide with bases. I hope now it's visible for you, obvious, да? Approximately like this. And this system of holes help us just to count holes, and because of counting the holes, we may understand what is the distance necessary in our case for locating the bushing. After we have seen some pieces now of this process, let's try to recollect the process altogether. First, we have prepared the working place, of course. Next, after preparation of working place, what we did? Located first flow, first line of instrumental rulers with respect to the mountain scheme information, locating these rulers onto the table of that is called loft conductor, or you may call it coordinate table, up to you, but use quite the same name each time when you are working with technological process. Locate and clamp. You see I have clamped it with special pins. Next, locate template onto the system of rulers according to position given in mounting scheme, and clamp template with pins. What is next? Next, you see I place it here locators. Locators compared their position with respect to the template, with respect to the template information given by hairlines. Also, they must be clamped, what I have not done yet, and maybe I'm not going even to do this. We have clamps of such design, let it be. Also, it seems like a bar, and this bar may be clamped by thread pin and nut to the table immediately. No, I don't need it much because I'm not doing for the grade right now, in contrary to students who usually do it in class. So I'm not going to clamp it. But in order you understand, I show you that we have here system of clamps. And after it's compared, checked, these two locators are compared with respect to the template, they are checked in contour. After this, we start working with second floor, second plane of rulers, because we need, for our measuring, we need double guiding base. What is next? Finally, we may place here the bushing in the hole. No, use how it's convenient to do everything with one hand. You can't even imagine, people. And bushing finding its position with respect to the hairline of axis. You see, with respect to the hole, base hole in template, bushing has correct position, and locator contour now will have correct position. You see, no, it's supposed to be clamped, of course. What else? You see the gap between bushing and hole in locator. What should we do? We should fill this clearance, this gap, with any easy hardening material. Usually we use special cement, cement, mounting cement developed in Scientific Institute of Aviation Technologies. And after filling everything with cement, I mean you place 4 bushings here, fill gaps with cement. Usually we use as a tooling syringe. Don't forget, please, don't write just cement. Either you need to write teaspoon there as a tooling, or you need to mention at least syringe. And no, about teaspoon, of course, it was a joke. I hope you understand. Next, after waiting 15 minutes, you already may remove these locators immediately from instrumental table, from this coordinate table. Once again, remind you that in your laboratory work it's called loft conductor, but really loft conductor is not just coordinate table. It's coordinate table combined with a drilling machine or even milling machine. In our laboratory class, we have just coordinate table, but we call it loft conductor. And what we did after we finished, what we did really, we produced locator of contour in which contour and axis of mounting holes are coordinated with respect to the contour, with respect to the plane, not contour, with respect to the plane, main plane, constructing plane of template. Template have represented for us the drawing, the ideal case of our manufactured item, let it be. And after all locators are ready, you may pass them to next stage of mounting the jig. Well, dear people, that was the first half of our laboratory work, manufacturing of locators. Now we need to produce the beam. What does it mean to produce a beam? You see, the beam is already exists. It's welded and welded rather roughly, as you may see. Real ones, they're even more rough. No one interested in very much high accuracy of these empty, they are called barrels. Now, we are interested only in correct position, not even all locator, but in correct position of this axis of hole, correct position of these holes. And we suppose to have here system of holes, as you might see in the toyish jig that is not far from the door. Да? We are interested to see, to align all these holes in correct position according to the drawing of the beam itself, once again. And how we're going to do this? In our coordinate table, we have seen the system of holes, but no system of holes in this table, yes? And what's this thing at all? It's also mock-up. It's a mock-up of instrumental stand in size 1 to 5. And in real life, these instrumental stands, they are huge, as I have already mentioned in other videos that you have got before laboratory class. Because of not good light, you can't see it now. But when it comes closer, you see it also has system of holes. Sorry, how to do it better. But certainly, scale is the same as I said, 1 to 5. Certainly, these holes are on greater distance. It's not 50 millimeters or 1 centimeter, which we have seen in coordinate table. Where another holes? Look, we have vertical ruler with such holes. You see it, да? Along the height. And we have longitudinal ruler with such holes along all the table. But now distance between these holes is, let's do it less. No, doesn't work. Greater, but not less. Okay. Distance between holes is 200 millimeters. Why? As I said already, the general size, the overall size of instrumental stand, some meters. And these some meters with holes of each 5 centimeters, it will be too much expensive. And in contrary to what we did in first half of laboratory work, where we had 2 coordinates only, in a plane actually. Yes, we had 2 flow of rulers, but it was anyway in the same plane. It was a horizontal plane. It doesn't come about measuring something in third coordinate. Here we have 3 coordinates along the table, where my pointer is, along the table, with height, with respect to the top, upward, and third coordinate is here, transversal ruler. Longitudinal ruler, vertical ruler, transversal ruler. Altogether we have 3 coordinate rulers which may help us to measure something. How they may measure something? You see here the wheel. In real life, of course, it's supposed to be engine. Usually it's electrical engine. In our laboratory toy, we have engine drive. In the view of student, let me not to move it right now. Once again, you have seen it in previous video. And what is idea of measuring here? This ruler, it's movable up and down. And you may hang here onto this ruler special adaptive fittings. This one. These adaptive fittings will interrupt video, sorry. These adaptive fittings, they also have holes, as you might see. And these adaptive fittings may be placed at any place of transversal ruler. And using these adaptive fittings, seems like you may measure distances which differ from 200 millimeters, 20 centimeters. Yes, but how to measure it? Look, fitting has 2 holes. One hole is for hanging the fork. Let's try to hang it. I'm afraid with one hand it's not possible, but I will try. Not possible. And another hole is for, no, you see here, supposed to be hanged. I will hang it at the pause of video. Another hole is necessary for using it in distant gauge. What is distant gauge? It's additional ruler, and this ruler, no, here it's also mock-up toyish ruler in size 1 to 5. And such a ruler may help you to measure another distances. And you see that gauge in turn has 2 system of holes, 20 millimeter, 220 millimeter, 200 millimeters, 20 centimeters at the top, supposed to be in real life, and another holes. If Your Highness will count how many holes you have, it's 10 holes, but should be 11 holes. If we divide this space 20 centimeters equally, should be 11 holes. First hole and next a hole which show us next 20 millimeters, each 20 millimeters. No, in this scaled one, of course, divide 20 onto 5 and you understand it's 4 millimeters. But one hole is missed, it's skipped, it's do not exist. And moreover, seems like these holes I have already shown this in previous video. Так, да. These holes, they not ideally coincide. You might see that they are certainly shifted with respect to the zero holes. Zero holes, they are these holes, mounting holes. And what this shifting? How it's appearing, this shifting? Maybe better even to place here 1, 2, 3. It will be more visible in this case. No, the shifting. Is it? No, as for me, it's visible. As for you, I hope also visible. That second line of holes, it's shifted. It's not equal in all these gauges. Let me to stop. And now you see what I did when video was interrupted. I place it here, this gauge. Gauge, place it with respect to coordinate system, you see. Gauge, place it onto 2 big holes with distance 200 millimeters. And using this gauge, I may move adjusting fitting, this, what is adaptive fitting, I move it. And because of another hole which exists in this fitting, ребят, с одной рукой это просто невозможно. I may find they are aligning these 2 pins on one line, in one plane. I may find what is the coordinate of mounting hole in fork with respect to one of these holes. Just counting the holes, I may understand what is the distance to this fork. And fork, first fork is our 0, will be approximately placed in order to have the tail of fork in the middle of barrel, approximately. Like this. You see, I hope you see. And after this, it's considered like 0 fork, 0 of our coordinate system. And with respect to this 0 fork, we are going to measure another sizes. Another size here. We will measure also using the main divisions of our ruler and distant gauge, like additional divisions, in order to find the position of second fork. About the height of the fork. In drawing, it's given approximately 5 millimeters. This approximately 5 millimeters we measure with usual devices, without these complicated ones. But after we did this, we must fix, we must measure where this place in coordinate system, because next we need to move up this ruler once again and to move table in order to find position of another couple of forks. Look, in the vertical ruler we have holes, and in transversal ruler on side you also have holes, but you see they are mismatched now. It's visible. They are mismatched. They are not at the same height. Moreover, on another side, we also have such holes. In order to align perfectly horizontal position of this ruler. How we may measure where these holes? With using the distant gauges also. Also selecting, searching which one is appropriate in this case, fixing them onto vertical ruler and counting the hole, what is the distance. How to measure distances in the lens with respect to the 0 fork. Forks are here, but rulers is very far. How to find position of these forks by using this ruler. And also you have here something like 0 bracket, 0 hole, but it's already not a fork. After first time you found position of this first fork, you have one more system of fittings. Let me not to insert them, please. also fitting with hole, and you will have some such fittings. In a drawing, it's said that you need to place these forks 45 millimeter distance, for instance. No, 45. How to measure this 45? First, fix here this first adaptive fitting. Next, using system of holes in longitudinal ruler and gauges, like this. Find position of another adaptive fittings, or not adaptive, distant fittings. This one, they are called distance because along the distance they measure something. And you see that position of fork actually does not coincide, not in the same plane with position of this fitting. Doesn't matter. Because when next, here we have also a pin, and next, when you move the table, of course we remove the pin, you are moving the table until position in this distant bracket does not coincide with this fitting. When they are penetratable, something similar what I have shown you in a jig, how to find correct position of locator of hole after we have moved it. Just because we have holes both in housing part and in the locator itself. And here it's similar story. We have hole in this bracket and we have hole in such a fitting, and we move table along the bed of this machine until these holes not met. And it means that we reached proper place here. Now, after I have approximately explained the principle of this machine using, because that is really, it's not just measuring tooling like it was with rulers, it's machine, it's supposed to have drive. No, in our case, it's not machine, it's mechanism, doesn't matter whatsoever. Idea is that we may measure 3 coordinates of each mounting hole, of each fork we need to locate here in a beam. And in a drawing also you have axis. Axis is shown with respect to the approximately with respect to the beam, but beam made very rough. It's rough and we're not interested in accurate beam. We're interested only in accurate position of these holes. That is why first we create the zero of our coordinate system. First fork is located very accurately. Next, with respect to the hole of first fork, using transversal ruler, vertical ruler and longitudinal ruler, we will measure holes in all another, we will measure position of holes in all another forks. And after we do this, what else we need to do? Also, you see the tail of fork is much thinner than the barrel, and it means that these clearances, they are filled, stuffed with cement. And let's try to outline the process altogether. What do you see? Instrumental stand. Prepare the workplace. It doesn't mean that you need to clean working place. It means that you need to make sure that all tooling at the place, that drive is working and so on. Prepare working place. What is next? Place the beam onto the table, movable table of place the beam onto movable table of instrumental stand. To pay attention, it's not immediately placed onto the table. It's placed on 2 supports. Why? Why 2? Why not 5? And where exactly it's placed with respect to this table? At the table, wherever, in order, it's approximately in the middle of table, approximately in the place which is convenient to work with. And why 2 supports we have? 1 and 2. Second, because in the jig this beam is rested onto two supports, onto two columns. In order to imitate naturally of course it does not completely imitates, to imitate the bending of this beam under its own weight, it's also placed onto the two supports which coincide with supports in a jig. Actually, their position correspond to the jig supports, to the jig columns. What you see next, after beam is placed, beam supposed to be clamped somehow. No, in our case, it's gate-like clamps. Approximately the same you have in real life. And after beam is placed, pay attention, it's not located on the table. Located when you have some coordinate system and you locate it accurately, measuring its position. Here it's just placed onto the table. After it's placed and clamped on the table, we start work. What is first? First, we need to prepare all this system of fittings and gauges. Place adaptive fittings into transversal ruler. Next, place distant fitting into longitudinal ruler. Place, not locate yet. Next, hang the fork, this fork type connector, to adaptive fitting hole, and measure position of first fork with respect to the barrel. First, how? Approximately in the middle this tail should be, and amount of millimeters of this distance between the bottom of fork and the top level, up level of the barrel, it's given in a drawing. Measure it approximately and fix it in this position. After you fix the fork in this position, it means that you fix it. We have here clamps. In real machine, it's approximately similar. After you fix it in this position, you may measure position of another fork with respect to position of zero hole, with respect to position of this fork. How? Using distant gauges, measure distance, first transversal distance to another fork, fix it in that measured position. What is next? Next, actually, you may fill already clearances with cement, and you may stop on this. But after you did it, you remove the pin, move up the ruler, and you do not understand. You move this beam, this table, movable table, with respect to the bed of machine, and you can't say where you have been in the next couple of beams of forks. You can't say where you have been here on heights, but it's extremely important to align all these holes onto one axis for you. Or maybe it's given the deviation of this hole with respect to this hole, for instance, 50 millimeters. You may measure it, yes, if you understand where have you been first time in this coordinate system. That is why here you also have additional system of holes. It's somehow similar to story about adaptive fittings, which has couple of holes. And you must use here distant gauges to measure position of transversal ruler with respect to vertical ruler and fix it here and on that side, these distant gauges, in order when you left this place and pass to the next couple of forks, you may find how to move transversal ruler down, how far you may move it in order to repeat this line. What about how to move it to longitudinal, in longitudinal coordinate? Also, insert pin, place it here, have already placed these distant fittings, insert pin into distant bracket and first distant fitting, clamp distant fitting in this position. What is next? Measure It means count the holes, using the distant gauges if necessary. Measure coordinates given in drawing by all this ruler system to the next hole in next distant fitting, and how many distant fittings you have. So many as you have couple of locators. Each place with locator, it will be measured, it will be coordinated with the first hole. And next, in order to find where to stop, you just removing this pin and moving the table into position until hole in another bracket and in another fitting and this bracket does not coincide. The whole process you already have seen in group. May read it if necessary in voice, but maybe not right now. And idea is that you are measuring position once again, locating, placing here some in the way which correspond to position of this beam in jig. If we're talking about top beam, you will see this. You will see this beam in upward position, in upside down position, and onto two supports because we have two columns in jig. Next, after it's placed and clamped, what do you need to do? First, locate first fork according to the drawing. Measure position of first fork and measure all another forks with respect to the zero fork position. Feel clearance between tail of fork and the barrel in a beam with a knot. Wait 15 minutes, remove the pin that have joined fitting and the fork. Next, move to the next position, repeat all the operation and so on. During the moving from station to station, let it be in a beam, you also moving this transversal ruler, and it means that position of transversal ruler of transversal thing must be somehow measured and fixed onto the vertical ruler. No, actually that's it. After both beams are made, ready, after all the locators are made, you have to place everything together in a shop already. If you had a frame-like jig, like you see, skeleton is frame-like. The whole skeleton is welded as one piece. No, it's typical for little jig, comparatively little. This jig is a bit higher than me. And for such jig, you may do frame-like skeleton. For big one, like really for wing, for fuselage, for even for stabilizer, more probably it's necessary to do column and beam skeleton. It means it's dismountable. It consists of pieces, and finally it will be mounted immediately at the place in a shop. Not in such a jig may be mounted immediately in tooling shop and just place it next. It's assembled in the tooling shop, and next it's placed mounted into manufacturing shop, in assembly shop. That one you may produce only by pieces because it will be great in size. And these even great pieces, you are removing from the place to place between shops, between tooling shop and assembly shop. And finally, mounting the jig immediately at the place in assembly shop. How you mount such a jig? You will mount the skeleton first, aligning the holes again in beams. It's already a subject of another laboratory work, so let's not talk about this right now. Anyway, you are aligning this using mounting plates. What is mounting plate? You may read in laboratory manual. You must read in laboratory manual. Real one we have here in our laboratory class. What do you see now? Real mounting holes. These fork types locators, they are I-type or eye bolt locators. They are placed here with very high accuracy, of course, so measured in instrumental stand, but they are placed with using the cement fixed. Here you see base hole immediately in one of the elements of this mounting plate. And what this mounting plate is necessary for? It's repeat some mounting holes in one plane. No, I can't show you it properly, but maybe it's visible for you. On back side, it also have mounting holes. It has another base hole and so on. And by using such mounting plates from both of sides of jig, in this side, on that side, you may align beams with respect to each other. And after this, you just need to hang locators by their mounting holes. But everything has been produced separately. One thing I'd like to show you, but I can't find you this thing right now. It's not at the place where it's supposed to be. What I may show you else is distant rulers. Or are distant rulers. You see real ones, and they have holes, as you might see, 200 millimeters. It's far than my palm. No? These holes, they are for hanging the distant gauges, which are detailized, as I hope you do remember, detailized devices for measuring the distance. And system of these rulers aligned in their turn may create you orthogonal place. So you may use orthogonal coordinate system. You may use such rulers even separately, not in the view of instrumental stand like it was in our laboratory work, but you may use them separately, these rulers, creating the orthogonal coordinate system. Can't find distant gauge, do forgive me. So must be, let's stop on this. Once again, we have only two ways how to produce the tooling. I mean assembly tooling, assembly jig. We may either measure position of each element in the jig, or we may use mock-ups which repeat the contours and holes of assembled items. And position of jigs elements, it's found by attaching the jig elements to these ideal mock-ups of assembled items. For instance, you see here mock-up of compartment of forward fuselage, of rear fuselage. In order to produce such mock-up, remind you, but something like we have there on the wardrobe. You need system of templates. Next, you produce such a mock-up. Next, you copy this mock-up via counter mock-ups. Via counter mock-ups, counter templates or counter jigs. You may copy them onto another mock-ups that we call mountain standards. Not visible here normally. That ones. And everything this is very long and extremely expensive. Wherever it's possible, better of course to use measuring. What is the problem with measuring? It's not so accurate. Whatever accurate these rulers are, they are not so accurate as using of mock-ups. Mock-ups are expensive but more accurate. Measuring is less expensive because you use universal equipment. Universal tooling that you may use it dozens of times for different aircrafts. Such a mock-up, it's repeat one particular aircraft, and it's not possible to use it instead of another aircraft. It's quite clear. And one more problem of instrumental approach, that accuracy of this measuring, it's not enough to work with GBH, with joint ball holes. So if even you made all the locators using the instrumental method, that save you money and time, once again, remind you. Anyway, if you have locators of GBH, of any type, look at this. There are locators of GBH for brackets in this jig. Design of these locators may be very different. locators of holes, what you see. Here is locator of bracket, the hole in SPA of the stabilizer, да? And locator of hole in SPA. Locator of bracket here. Not much visible, sorry. What? No, visible, I hope. The bracket on the SPA and locator of this bracket. If you have something like this, you must do mockups. But mockup may not repeat all the contours. Mockup may be just mockup of gauges, of junction. And in this case, it's called gauge of junctions, gauge and counter gauge of junction. My dear people, what I forgot to say, coordinate fixing and base holes. They may be measured. In case you need coordinate fixing holes, CFH, or in case you need BH in your jig, locators of CFH or BH. In this case, you may use instrumental means. In case you need GBH, you need to use mockup. Mockups are more expensive but more accurate, measuring, locating, whatsoever. And instrumental approach with measuring is cheaper but more expensive. That's it.